Good morning, happy Friday. Today is day 109, and hopefully by now you should recognize that for today, our exploratory problems are going to be focusing on the rotation. So at this point, you should have already read today's objectives and key terms, that's right here, and you and your partner should have already completed the purple box problems, the exploratory problems, and now you're watching the video recap to see how you did get help on anything that was a little difficult. After you watch this video, you'll be going on your own, working through those blue box problems that we call the practice problems. So let's start by taking a quick look at today's objectives and key terms. Specifically, today is going to be the first day that we focus on the rotation. We spent earlier this week focusing really on translations and reflections. Today we're going to move on to the rotation. And at its simplest, the rotation is about spinning an object or spinning points around a different fixed point that's going to help you. Here, the fixed point is the origin, and this figure F, the shape that looks like an F, was rotated in a clockwise direction. You see the top of the F is now kind of pointing in a downward right direction because it's spun down. This point right here that was very close to the point of rotation doesn't really rotate much, but again, we see the whole figure was rotating or spinning downwards. That's what a rotation is at its most basic. You're going to start seeing some key terms more often. You're going to congruent we're familiar with. That should mean same size, same shape. The big key term we're going to talk a lot about, and you should already be familiar with a bit, is what a vertex is, or in the plural, vertices. And that's just the corners of the different shapes that we're working with. It's any point where two lines meet each other is called a vertex. So when we have a shape, every corner of the shape counts as one of its vertices. So your first job today, part one, you were just going to label the coordinates for the red point. And then part two, so we're going to do part one and part two together here. Part two asks you specifically, you're going to rotate this red point, point R, 180 degrees in a clockwise direction. And the origin is going to be the center of rotation. The middle of the graph is the center of rotation. So really the entire graph is going to be spinning around 180 degrees. You were asked to call this point P. The biggest thing that you and your partner needed to recognize is that a rotation has 360 degrees in total. So 180 degree rotation is going to be exactly halfway around a graph. Hopefully we know the coordinates were 2 and 3 for the red point. So if we spin the entire graph exactly halfway around 180 degrees, then P is going to go to the exact opposite. The X is going to go from +2 to -2. The Y is going to go from +3 to -3. If you had taken this graph, and if you had spun the entire graph 180 degrees around, you use the origin as the center of rotation, point R would spin to the exact opposite half of the graph. We see here, if we make quick little lines, a line between point R and the origin, and a line between point P and the origin, we see a 180 degree angle. If I had done that perfectly, both of these lines would be perfectly straight. We see a 180 degree angle, origin to the new point, old point, origin to the new point, 180 degree angle. The other two rotations we were asked to do, instead of rotating 180 degrees clockwise, we were asked to rotate 90 degrees clockwise. So again, we're going to use point R each time. For part three, we do 90 degrees in a clockwise direction around the origin. And then for part four, we're going to rotate 90 degrees in the counterclockwise direction around the origin. And those are going to be the green and the fuchsia pink points respectively. The key with a 90 degree rotation, we're going to talk about this more in the base for it. But if I spin 90 degrees, it's going to rotate one quadrant and the coordinates are going to flip. I spin 90 degrees, the first thing I need to know, a clockwise direction spins around the way that a clock would. If you picture this as a clock hand kind of pointing at 1 o'clock, it's going to spin clockwise for a quarter rotation or 1/4 of the way around. What we see here, the big important key to see, is if I draw a line from the origin to the red point, and if I draw another line from the origin to the green point, what kind of angle do we create there? We create a 90 degree angle at that point. I see again the origin was my center of rotation, so if it's a 90 degree rotation, I should see something that looks like a right angle or a 90 degree angle from the new one and the old one as we take a look here. We'll notice all that really happened to the coordinates It used to be 2 for x, 3 for y. Now it's 3 for x and -2 for y. So essentially the x and the y coordinate flipped, and then the quadrant 4, tells us x would be positive, y would be negative. 90 degrees in a counterclockwise. Counterclockwise is spinning opposite of a clock. So if we were at about 1 o'clock, we would have to spin backwards towards 12 o'clock and back into this quadrant of the graph, quadrant 2. So again, from quadrant 1 to quadrant 2, we see as a counterclockwise spin going from 1 to 2. And again, the coordinates are going to flip here. One last time, we're going to go ahead and draw. Here's our old line segment, origin to the red one. Here's our new one. And we're going to see this creates a 90-degree angle again. What are the coordinates at that point? We see it used to be 2 and 3. Now it's flipped. The x is at -3. Again, because it's quadrant 2, the x has to have a negative, and the y is a +2 right here. We see it flip from 2 and 3 to -3 and 2. That's a lot for rotations. We're going to keep talking about it today and next week. So again, if some of this doesn't make sense, please grab me, ask some questions, talk to your neighbors. For the second part, part B today, you're going to be asked to rotate 180 degrees around the graph for an entire figure. I'm going to go through this pretty quickly out of the interest of time. So if we're going to rotate 180 degrees, I'm going to go ahead and take a look at this big triangle. I'm going to rotate it clockwise 90 degrees. That's once. Clockwise 90 degrees again. Now it's done 180 degrees. I rotated 2/4 of the way around the graph. A would go from 2 and 5. A is going to become x all the way to -2 and -5. Remember, 180-degree rotation, it spins to the opposite part of the graph. So that's where A would be located at. Again, A is now becoming point x. A, B, C was going to x, y, z, so A will become x, B will become the point y, and then C will become point Z. You can fill in the coordinates for the purple triangle on your own. For part 4, they ask us to explain what happens when we rotate the entire shape 180 degrees, and we should be recognizing by now 180 degrees flips the entire object upside down on the opposite half of the graph. Again, this went pretty quickly. If you've got questions, please let me know. Thanks for getting to the end of the video. Good luck on the rest of Friday.